Okay, in this video, we are going to look at how we write equations once we have found groups in Karnaugh Maps. So if you have not watched the previous two videos on first filling in the Karnaugh Maps and then finding the groups within the Karnaugh Maps, I recommend you go watch those videos first. So I'm starting off again with a 2-input Karnaugh Map. We'll start easier and work our way up. And I can see that in this group, I have a group of 2 ones here that has been denoted by the fill color in the background. All right, now when we are writing equations, what we are looking for is we are looking for what inputs have the exact same value for every single spot in that group. Okay, so in this first cell up here, this is when A is 0. So for that cell, A is 0 and B is 1 in that cell. Okay, so A is 0 and B is 1 in that cell. Where in this cell down here, I can see that A is 1 in that cell, and B is 1. So when I look at those values, I can see that A changes. All right, so here A is 0, here A is 1. So it's not consistent for every cell in that group. So I ignore A. All right, but I can see that B is 1 for every cell in that group. So that is the key thing that I want to remember, that B is 1. So again, I'm looking here, A changes, and B is always 1. So the equation for this group, let me clear my screen quick. All right, so that's mostly clear. So my equation for this group, remember, I'm looking at B is 1. So the equation for this group is just B. All right, let's take a look at another example. All right, so here we can see another 2-input Karnaugh map. And here I have a group of ones here. And again, we are going to look at what values are consistent for this entire group. So first of all, I can see that the values of B change. So I know I'm not going to need a B. And I can see that the value of A is always 0. So I know I'm going to need a letter A. Now, how do I denote that A is 0 instead of A is 1? Well, remember when B was always 1, we just wrote a B. So we would think that if A is always 1, we would just write an A. Well, here A is always 0. It's the opposite. And if we think back to our logic gates, the opposite was given by a not gate, so an exclamation mark. Or if we're using standard logic symbols, we could write not with a line over the top, but those are hard to type. So we are using the exclamation A as the not. All right, so the equation for this group is not A. And we'll look at another example. All right, so now we're going to look at the 3-input Karnaugh maps. And I can see I have 2 groups here. So let's start off with the nice big green group across the bottom. And hopefully by now you're learning that when you're in multiple columns, if you take up the whole row or the whole column, that means that all of these variables that go across there are going to disappear. And it's only going to be the A in this case, because I can see here B changes from 0 to 1, and here C changes from 0 to 1. So both B and C change for cells in this group. They're not consistent. So my green group here is simply going to be A. All right. So let's now look at my reddish pinkish group over here. And I can see that the value of A changes for those spots, so I'm not going to worry about that. Now I'm going to be looking at the values of B and C here. Well, they are consistent for every spot in that group. B is always 1 and C is always 0. So my red group here is going to be, now B is 1, so I'm going to have a B. And C is 0, so I'm going to have a not C. And I needed something in between those. So what we're going to do is we're going to, it's an and is what we're putting in between them. But to simplify our equations, because the ampersand is a little bit hard to draw for some people, and it is not one of our standard logic symbols. It is a standard programming symbol for and. But what we're going to do is we're going to change to a dot for our Karnaugh mapping. So we're going to go B and not C here. So now I have two pieces of this equation. So what I need to do is I need to put these together into one equation. So in this case, I'm going to assume that this output variable was x. We're going to say x equals A, or, and in our class we're using or as the pipe symbol, the programming logic symbol. So A or B and not C. All right, so that is our final equation for this truth table, for this Karnaugh map right here. Okay, so the next one we're going to look at a 4-input Karnaugh map. So again, I can see I have a single column here, so this is going to be the easiest one to do. All I'm going to need to do, oops, I need my pen tool back on. All I'm going to need to do is look at the values of C and D. I can see they're both 1. So my green group is going to be C and D. All right. And now we'll look at my red group here. And again, this is one group because these rows are adjacent. So now I'm looking at the values of C and D here. And I'm also going to be looking at the values of A and B in these bottom 2 rows. All right, so first I will look at A. I can see that A is 1 in both of those rows, so I know I'm going to need an A. So I will write down an A. I can see that B changes, so I'm not going to need a B. I'm going to look here. As I go across, I can see that C changes from 0 to 1, and I can see that D is 0 in both of those. So I know I'm going to need a not D, and I'm going to need an or between my 2 groups. So that is the equation for this one. One final thing to note, just like edges are adjacent, all 4 corners can be adjacent as well.